In this video, we're going to talk about the idea of a limit. So we're going to approach it more from a graphical standpoint, not so much rigorous, but we're going to look at some examples to try to kind of nail in what is the concept of a limit. So from an informal definition, we're going to start out by saying that the limit is going to be the value that a function f of x approaches as x approaches some particular value. Now, the notation for a limit looks like this, and we're going to read it as the limit as x approaches some number a of f of x is equal to some number L. So if you've never seen the notation, it's probably a lot. But if we look at this picture on the graph, the idea is you're going to have some function and we're going to consider some x value, so some value along the x-axis. In this particular example, we're going to call that x value a. So what's going to happen is we're going to consider getting really close to it. And right now we're going to look at from either side. So you're just getting closer and closer and closer to that number a. So the limit is going to be what the function is doing as that is happening. So we go up to the number a, and you can see that here would be f of a, right? This normally is what we would call f of a. Well, we're going to call f of a equal to L. Okay, so we're just going to give f of a some number L. Well, because it doesn't always have to be f of a, because sometimes this may or may not be defined. So right now it is f of a, and the limit and f of a are equal, right? We're going to call it L. But even if this were an open circle, we would still say it's getting close to some number L. So we're saying, where is the function going, right? Not what happens when it actually gets there, but if it continues this behavior, where would it actually arrive to? And so that's why we use the term approaches, right? So it is approaching this value L, right? When it gets there, it may or may not be equal to the value L, but that's not what the limit is. The limit is what is it approaching? So where is it headed, right? If it continues down that behavior. And so we consider one and two-sided limits to get the idea going. So we're going to have a left-hand limit, which means you're going to come in on the left side of the value a. And to note the left hand, we put a little minus up here. And then you're going to consider a right-hand limit, which means you're going to come in on the right side of a. So we're going to denote that with a positive value. So over here, this would be approaching a from the right, where this would be approaching a from the left. Now, a left and right hand limit can both have their own values. So they're not always equal to the same number. So this could exist and have a value. This could exist and have a value. But the note here says that in order for the actual limit to exist, those two values need to be the same. The left and right hand limit need to be the same. So we're going to just explore a little bit and kind of get our mind around this. So if we come down here, this is just kind of saying a lot of the same stuff that I just said, right? We're saying here that as x approaches a along the x-axis, L is going to be what the y value or f of x is getting closer to. Okay, so we're just kind of getting our comfort level around the word or the term and the concept of approaching, right? And remember, like I said above, that's the left hand, this is the right hand limit. So if we look at the first example, so this is just one-sided limit. So here's three quick little problems and they refer to this graph. So if we're looking at our first example, this one says, number one, what happens, right? What is the limit as x approaches 3 from the left of f of x? So here's our function. Here's 3. So if we get close to 3 from the left-hand side, our function is going up infinitely. So what we're going to say is we're going to say that it approaches infinity. Now, since we put infinity here, technically that is not a real value number. So you could say the limit doesn't exist, but if you can say infinity, it gives some sort of direction that we know it's positive infinity as opposed to negative infinity. Now, as we look at number 2, what happens to the function as x approaches 3 from the right? So 3 from the right, we're going this way. Okay, so we are now approaching minus infinity, negative infinity. So what would we say about the limit as x approaches 3 altogether? Well, the left and right-hand limits are not the same. Not that these values could be equal, but they're not the same. So we're going to say here that this limit, we'll just say does not exist, right? So DNE is does not exist since these are not approaching the same direction. But both of them will indicate here that you have a vertical asymptote, right? We have a vertical asymptote. Now let's go to the second example. This one is an example. It's called removable discontinuity, although at this point of a lesson, you probably didn't hear that term yet. But if you're kind of doing a review, you've probably seen that. And so let's go through. We're mainly going to investigate what's happening around -4. So this one says around -4 from the left. What's the function doing? So that means we're coming in this way. You can see your function is going there. Now, of course, you see it's undefined when it gets to -4, but until then, we would say that it's approaching +5. So over here, we're going to say equals 5. If we approach the same value, -4, but we come in from the right side, it is approaching the same value of 5. Which means that for question 3, the limit as x approaches -4 is actually going to be equal to 5 because the left and right hand limits are the same. You can see that that actual limit is going to be negative, at -4 is going to be 5. Now, f of -4, well, at -4 itself, it's an open circle. So this is just going to be undefined. Okay, so f of -4 is just undefined. But what about f of 6? Okay, f of 6, it's undefined here, but it's a solid point up here, which means that f of 6 has a value of 5. So we're going to say this one equals 5. Okay, so we're going to look at example 3, some more one and two-sided limits. The first one starts out with x approaching -5, but we're coming in from the left side. So this one is going to positive infinity. From the right side, as you approach -5, we're also going to positive infinity. Okay, so we still have a vertical asymptote there, as you can see, but to indicate the limit itself, we're going to say that that approaches negative infinity. But of course, as an actual value, you would say it does not exist. But the infinity gives an idea of what's happening. Now, at -5, does this exist? Right? At -5, remember, this is a vertical asymptote. So f of -5 is never going to actually take on a value. So we're going to say this is undefined. And then the last question, number 5, if you look at the limit as x approaches 2. So if we come in from the left and right, you can see we're squeezing in on this value 5. So here we would say that the limit as x approaches 2 of f of x is equal to 5. Now, even if this were, let's just say this were an open circle right here, this limit would still be equal to 5 because it's the direction that it's going, right? They're both from the left and right headed to the value 5. So when it gets there, of course, it may or may not be equal, but that's not what the limit is about, right? It's about where it's headed. And so this would still be equal to 5, whether or not it's defined when x is 2 or not. Okay, we have some, let me slide this over. We have some more. So number 6, if you look as 3 approaches, x approaches 3 from the left, this is coming up to 1. 3 from the right is coming up to 1. And so the limit is 1. But here's an example like we said above, right? Even if that was an open circle, here's an example where it is. And so at 3, you have an open circle. So you may want to say that f of 3 doesn't exist or is undefined. But you can see down here it is, right? So it's -5. So this at 3 has a limit of 1, but a value at -5. So that's okay. Those can be different, right? So just make sure the limit is about where it's approaching, not what happens when it actually gets to the value. Okay, this one is more limits dealing with infinity. So x approaches -2 from the left. So -2 from the left, as you come in this way, the function is going to positive infinity. What about as x approaches negative infinity? All right, so we have not used positive and negative infinity for the x values in any examples yet. So now you're looking at what's happening to the function as you just continue going way out here. Well, you can see the function is going to eventually approach this horizontal asymptote. So we're going to say the limit as x approaches negative infinity is equal to -1. So when you have a minus infinity or positive infinity, the x is approaching, that's when we're going to bring in the horizontal asymptotes, right? So right now we're just doing it graphically. Now, -2 from the right, you can see that's going to negative infinity. And then positive infinity, so as we go out this way, here we're approaching that horizontal asymptote again. So this value would be -1. And then our last example down here kind of puts a bunch more of it together. So, and maybe brings in a new concept or so. So if we look at number 1, the limit as x approaches -9 from the left. So from the left, we're approaching 4. So this one is 4. From the right, we're approaching the value 2. Right? So we're going to say this equals 2. Now, the limit at sorry, this one I think is supposed to be a -9. So the limit at -9, your left and right hand limit are not equal. So the actual limit, we would say here, does not exist. Now let's look at 0. Okay, what's happening at 0? Well, now we're not looking at the left and right separately, by the problem, but we really do need to consider that because here, to the left and right of 0, both sides are going to minus infinity. So we could say that this is going to minus infinity, but of course, as a number, we would say it doesn't exist. Now, what happens at x as x approaches 10? Right, so that's here. So you can see as you come in from the left and the right, you're approaching the value of 4. As x approaches minus infinity. So if we were to just keep traveling out this way, well, this thing is supposed to be drawn as if it just continues to increase. So we would say that this goes out to positive infinity. Okay, so that's talking about pretty much the end behavior. Now, if we go out to the right, this way, notice this is a constant function. So as we go out to the right, the value of f of x is always actually going to remain the same. So it's going to always be 4 because that's a constant function. Now, f of negative 9. Well, f of negative 9, that's defined here, not here. So this one would be equal to 4. F of 5, you can see here's an open circle. It's undefined, but it's defined down here. So we would say equals negative 2. And then f of 15. F of 15 is way out here. And so you can see that value is going to be 4. Okay, and then since I erased that 5 that was right there, let's add it back down here. Okay, now what happens as the limit approaches negative 5? So at negative 5, this one is interesting. So here's negative 5. And as you start coming in this way and this way, this is doing a behavior of what you call oscillating. So it's jumping from the function value is jumping up and down, and it doesn't actually kind of zone in on any one value. So it's just constantly changing value as you get close to negative 5. So here we would say that the limit does not exist. However, you could have an example of oscillating where it tends to calm down and approach a value, but in this example, it's just kind of all over the place. So we would say this one does not exist. So that gives you an overview of the idea and the definition of what a limit is. So just getting the concept down. There's a lot more we can do with this, and so there's going to be future videos for that. So let's just say we'll see you in the next video. Keep practicing and absorbing the idea of what is a limit.